Hello grade 9 students. Welcome to another virtual class. I am Miss Madhu Vadke. We have completed our study in chapter 7, triangles. In today's video lesson, we will revise all the concepts that we covered in this chapter. So let's start by asking, what is congruency? Or what does congruence mean? You may like to think of it as an equal to sign with a sleeping S on it. But let's take a moment to conceptualize this term. So let's look at this running shoe. I can somehow duplicate this shoe and create an exact replica of it. So I can say that these two shoes are congruent. Even if I change the color of the second shoe, or I rotate it by certain degrees, they are exactly the same shoes because they have same shape and same size, no matter what the orientation of second shoe is. So we can say that two figures are congruent if they have same shape and same size. Let's extend this idea of congruency to triangles. We can apply the same thinking to triangles and compare them to say whether they are congruent or not. We know that two triangles are congruent if their corresponding sides and corresponding angles are equal. This applies even if the two triangles do not have the same orientation. And visually, it's not easy to say whether they are congruent or not. So here is where our theorems come into picture. We use these theorems to say whether these two triangles are congruent or not. So if we name the triangles as triangle ABC and DEF and mark such that angle B is equal to F, angle A is equal to angle D, and angle C is equal to angle E. The corresponding sides will be AB equal to DF, AC will be equal to DE, and BC will be equal to EF. So symbolically we can write triangle ABC congruent to triangle DFE. It is important to write the order of congruency for these triangles correctly, because if we write a wrong order for the congruency of these triangles, then the corresponding angles and sides that are equal will not match. So in order to say that two triangles are congruent, do we need all these 6 equal parts to be given? No. We have seen that if only 3 corresponding parts are given equal, that is sufficient to show that these triangles are congruent. So this gives us criteria for congruence of these triangles. So let us look at the congruence criteria that we have learned in this chapter. The first criteria was side angle side. The second criteria was angle side angle. The third criteria was angle angle side. Fourth criteria was side side side, and the fifth criteria is RHS. Further, we will understand why these theorems prove congruency and which theorem will be applicable in a particular question or situation. Let's explore each of these criteria individually. According to side 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 congruence rule, if in two triangles we have all 3 corresponding pairs of sides equal, this means that they have same length, then the two triangles are congruent. So this will be applicable even if we rotate the triangle and change its orientation. These two triangles will have exactly the same shape and same size. We can check this by overlapping. And so we can say that these two triangles are congruent by SSS criterion, which means that not only their corresponding sides are equal, their corresponding angles are also equal. According to SAS congruence rule, if we have two triangles in which two corresponding sides are equal and the angle contained between these two equal sides is also equal in these two triangles, then these two triangles will be congruent. That means these two triangles will have same shape and size, no matter what the orientation of these two triangles will be. So when we are given these three parts, we can say that these two triangles are congruent by applying SAS rule. Notice that the angle is contained between the two equal sides. According to ASA congruence rule, two triangles are congruent if one pair of their corresponding sides is equal and two corresponding angles in these two triangles are equal. And this will apply even when the triangles do not have the same orientation. So we can say that these two triangles are congruent by ASA. Notice that the corresponding sides that are equal are contained between the corresponding equal angles. According to angle-angle side congruence rule, we say that two triangles are congruent if two corresponding angles of these two triangles have the same measure and a side of these two triangles is equal. Notice that the two angles that are equal are consecutive angles. That means the side is not included between the equal angles in these two triangles. This is an extended rule that follows from angle side angle, which is based on this principle that if two angles in one triangle are equal to the corresponding two angles of the other triangle, then the third angle will also be equal in these two triangles, as it follows from angle sum property. The last rule is RHS congruence rule. R stands for right angle, H stands for hypotenuse, and S stands for side. This particular rule applies only to right triangles. So according to this rule, two right triangles are congruent if their hypotenuse are equal in length and another pair of corresponding sides in these two triangles are also equal. Also, we have a right angle equal in these two triangles. So we have three parts that are equal in these two triangles, and hence they are congruent by RHS criteria. Now let's try to answer why angle, angle, angle cannot be a congruence criteria. Consider this triangle in which one angle is 90 and the other two angles are 60 degrees and 30 degrees. Now if we have another triangle that has exactly same shape and size as this one, then these two triangles will be congruent no matter what the orientation is, because all six parts are equal. So what I just did is that I reduced the size of the triangle. So if we compare the lengths of the sides of the second triangle, they are reduced compared to the length of sides of the first triangle. Does that apply to the angles as well? Have the angles of this triangle also reduced? Let's check. We can see that one of the angles is 90 and the other is 60, and the third one is still 30. So we have a smaller triangle with same angle measures, 60, 90 and 30 degrees. So even if all three pairs of corresponding angles in these two triangles are equal, it doesn't imply that these two triangles are congruent. Now let's understand why SSA cannot be a congruence criteria. Let's consider a triangle ABC in which we know two consecutive sides and we know an angle. Let's draw another triangle with the same measures. So I'm constructing a triangle PQR such that angle Q is equal to angle B and PQ is equal to AB. The third corresponding part that is equal in these two triangles is AC and PR. However, I do not know what is angle P. So I can place PR like this to form triangle PQR. I still have PR equal to AC. But clearly we can see that these two triangles are not congruent because they do not have same size and same shape. So understand, if we are not given this angle, then PR can be drawn in two ways. Placing PR like this and placing PR like this. This gives us two ways in which we can draw triangle PQR. So if we know two consecutive corresponding sides in two triangles equal and an angle equal, it does not imply that the triangles will be congruent. Let's recall what is isosceles triangle property. If we have a triangle in which two sides are equal, then the angles opposite to these two sides will also be equal. So in triangle ABC, AB equal to AC, this implies angle B will be equal to angle C. The angle opposite to AC is B and angle opposite to AB is C. Likewise, we can write the converse of this theorem. That is, if in a triangle we have two angles equal, then this implies that the sides opposite to these angles will be equal. So PR will be equal to PQ. The side opposite to angle Q is PR and side opposite to angle R is PQ. While solving three exercises of this chapter, we came across these three words: median, altitude and angle bisector. So let's recall each of these. Median is a line that is drawn from the vertex joining the midpoint of opposite side. So if D is the midpoint of BC, then AD is a median. And we can say that BD will be equal to DC. An altitude is a line that is drawn from the vertex of a triangle such that it is perpendicular to the opposite side. So PM is perpendicular to QR. So if PM is an altitude, then we can say that PM is perpendicular to QR. If in a triangle a line is drawn from the vertex such that it bisects the angle at that vertex. So if DG is an angle bisector, then we can say that angle EDG is equal to angle GDF because it bisects angle D. We also came across the term perpendicular bisector. If I have a line AB cut by another line L such that the angle between these two lines is 90 degrees and it cuts AB at a point which is midpoint of AB. That means AO is equal to OB. So if L is perpendicular to AB and OA equal to OB, then L is a perpendicular bisector of AB. So what are the type of questions that can be asked? We have done different kinds of problems where we have used different criteria to prove the triangles congruent. We also came across figures in which the triangles are overlapping. So the best way is to separate these triangles or draw these triangles separately in your notebooks and then mark the corresponding sides and angles that are equal. This gives a clarity in understanding. Also, there were indirect questions where you are not directly asked which triangles to prove congruent. If the question is to show the sides or angles equal, then we have to identify the triangles that contain these sides from the figure and then show them congruent, and hence the corresponding parts of these triangles will be congruent. So using this method we have solved many questions, and all of these questions have the same format for answering. We should start our answer with what is given in the question, followed by what we have to prove. So we have to understand the question and segregate what is given and what is to be proved. Figure needs to be drawn if it is not given in the question. That means the figure also has to be interpreted from the question if it is not given. I have shown in video lessons how to go about this. You have to break the question in parts, small parts, and start from the basic information that is given and then build up. In very few questions we may require some construction in order to be able to use the concepts of congruency that we have studied. So it has to be stated if we are using it. And then we write down the proof, which contains statements with a valid reason for each statement. Practice enough questions by writing so that you understand the format of writing. Also, make sure that the figure is drawn with pencil and ruler. For the current year, we have revised syllabus for 9th standard maths. So you are expected to learn the proof for isosceles triangle property, and all other statements are to be understood without a proof. Also, if you notice that angle side angle is not mentioned in this syllabus. However, we have been studying angle side angle from lower classes, so we are expected to know it. Also, the questions in the 3 exercises of this chapter have mixed questions, where in some questions angle side angle is applicable. Hence, you are supposed to know it. Here is the deleted part of this chapter. The proof of angle side angle is deleted. However, I have already mentioned this theorem has to be learnt and applied in questions. And all topics that are related to inequalities in a triangle are deleted. So this means that the 4th exercise, 7.4 is deleted. With this, we come to the end of this video lesson. I have attached a mind map for this chapter. If it is not visible, you can download it from Google. It is taken from Oswald. Also, if you want, you can create your own mind map for this chapter, which will help you in revising the concepts. See you in the next class with a new chapter. Until then, goodbye.